The CSA Canadian Standards Association designation Class 1, Division 2, Group B is not the same as the NEC National Electrical Code designation Class 1, Division 1, Group D, T2D. The CSA designation is more stringent than the NEC designation, providing a higher level of protection. Providing an NEC-rated motor for a CSA-rated application may not meet the specific requirements of the end-user's AHJ authority having jurisdiction. The AHJ may deem the motor as not suitable for the hazardous location, leading to potential safety concerns and non-compliance. It is strongly recommended to provide a motor that meets the exact CSA designations specified. If possible, it is advisable to request that the end user re-evaluate the required motor rating. They may be able to accept an NEC-rated motor with a higher level of protection, for example, Class 1, Division 1, Group D, T2D, which would still provide adequate safety for the application. NEM7 switches are suitable for use in Class 1, Division 1, Group D hazardous locations and can be used with an NEC-rated motor. However, they may not be appropriate for a CSA-rated application as the CSA designation requires more stringent protection levels. To ensure compliance and avoid potential safety hazards, it is crucial to meet the specific motor rating requirements. If a CSA-rated motor is required, it is essential to provide one that meets that designation. Providing an NEC-rated motor may lead to non-compliance and safety concerns. The differences between CSA and NEC designations for hazardous locations, particularly concerning electric motors, is important. These standards define the requirements for electrical equipment used in areas where flammable gases, vapors, or dust may be present, creating a risk of explosion or fire. Understanding these differences is crucial for ensuring safety and compliance in such environments. The National Electrical Code, or NEC, is a widely adopted standard for electrical installations in the United States. It classifies hazardous locations into classes, divisions, and groups based on the type and nature of the hazardous materials present. Class 1 locations involve flammable gases or vapors. Class 2 locations involve combustible dusts. Class 3 locations involve ignitable fibers or flyings. Divisions further categorize the likelihood of the hazardous material being present. Division 1 indicates that the hazardous material is normally present or may be frequently present. Division 2 indicates that the hazardous material is not normally present but may be accidentally released. Groups classify the specific type of hazardous material. For Class 1 locations, these groups include A, B, C, and D. Group includes acetylene. Group B includes hydrogen. Group C includes ethylene. And Group D includes propane. Temperature ratings, such as T2D, indicate the maximum surface temperature that the equipment will reach under normal operating conditions. This is critical to prevent ignition of the surrounding hazardous atmosphere. The Canadian Standards Association, or CSA, is a standards organization that develops and certifies electrical equipment for use in Canada. While CSA standards are similar to NEC standards, there are some key differences. CSA also uses classes, divisions, and groups to classify hazardous locations. However, the specific requirements and testing procedures may vary. The differences in the grouping of gases is a significant area where CSA and NEC standards diverge. For example, a Group B motor under CSA standards, designed for hydrogen environments, often represents a higher level of protection than a Group D motor under NEC standards, which is designed for propane or similar gases. This is because hydrogen is more easily ignited than propane, requiring more stringent safety measures. When evaluating a motor for use in a hazardous location, it is essential to consider the specific requirements of the AHJ, or authority having jurisdiction. The AHJ is responsible for enforcing electrical codes and standards in a given area. They may have specific interpretations or requirements that go beyond the basic NEC or CSA standards. If a customer requires a motor with a specific CSA designation, it is generally best practice to provide a motor that meets that exact designation. Using a NEC-rated motor in a CSA application may not meet the AHJ requirements and could lead to safety concerns or non-compliance. There are situations where an NEC-rated motor with a higher level of protection may be acceptable in a CSA application. For example, a Class 1, Division 1 motor may be considered equivalent to or better than a Class 1, Division 2 motor. However, this determination is ultimately up to the AHJ. To determine whether an NEC-rated motor is acceptable in a CSA application, it is essential to consult with the AHJ and provide them with detailed information about the motor's construction, testing, and certification. The AHJ will review this information and determine whether the motor provides an equivalent level of safety. If the customer is open to re-evaluating the required motor rating, it may be possible to find an NEC-rated motor that meets their needs. This may involve conducting a hazard assessment to determine the actual risk level in the location and selecting a motor with an appropriate level of protection. In some cases, it may be possible to modify the environment to reduce the hazard level. For example, improving ventilation or removing potential sources of ignition. This could allow the use of a less stringent motor rating. NEMA 7 switches are designed for use in Class 1, Division 1 hazardous locations where flammable gases or vapors may be present. They are constructed to contain any explosion within the enclosure and prevent it from igniting the surrounding atmosphere. While NEMA 7 switches are suitable for use with NEC-rated motors in Class 1, Division 1 locations, they may not be appropriate for all CSA-rated applications. The CSA designation may require more stringent protection levels, such as explosion-proof enclosures with specific flame paths or increased ingress protection. To ensure compliance with CSA standards, it is essential to verify that the switches meet the specific requirements for the hazardous location. This may involve reviewing the switch's certification and testing documentation or consulting with a qualified electrical engineer. Selecting the correct motor and components for hazardous locations is critical for ensuring safety and preventing explosions or fires. It is essential to understand the differences between NEC and CSA standards and to consult with the AHJ to ensure compliance with all applicable requirements. When specifying motors and other electrical equipment for hazardous locations, it is critical to provide detailed information about the application, including the class, division, group, and temperature rating. This will help ensure that the equipment is properly selected and installed. It is also important to maintain accurate documentation of all equipment certifications and testing data. This documentation may be required by the AHJ during inspections or audits. Regular inspections and maintenance are essential for ensuring that electrical equipment in hazardous locations continues to operate safely. This includes inspecting the equipment for damage or deterioration, testing the grounding system, and verifying the integrity of explosion-proof enclosures. If any problems are identified, they should be corrected promptly to prevent potential hazards. Training is also essential for personnel who work in hazardous locations. They should be trained on the hazards present in the location, the proper procedures for operating electrical equipment, and the steps to take in case of an emergency. This training should be provided on a regular basis to ensure that personnel are up to date on the latest safety practices. Several resources are available to help engineers and technicians understand NEC and CSA standards for hazardous locations. These include the NEC Handbook, the CSA Electrical Safety Code, and various industry publications and training courses. These resources can provide valuable guidance on selecting, installing, and maintaining electrical equipment in hazardous locations. In summary, understanding the differences between CSA and NEC designations is crucial for ensuring safety and compliance in hazardous locations. Always prioritize meeting the specific requirements of the AHJ and providing equipment that is properly certified and maintained. This will help prevent accidents and ensure a safe working environment. The NEC is updated every 3 years, and CSA standards are also periodically revised. Staying up to date with the latest revisions is important to ensure that electrical installations comply with the most current safety requirements. Changes to the codes can affect the selection, installation, and maintenance of electrical equipment in hazardous locations. For example, revisions may introduce new classifications or requirements for specific types of equipment or applications. It is important to review the latest code revisions and understand how they may impact existing or planned electrical installations. Changes to the NEC are typically proposed by industry experts, code officials, and other stakeholders. These proposals are reviewed by the NEC Correlating Committee and various technical committees. The committees consider the technical merits of the proposals and their potential impact on safety. The CSA standards development process is similar to the NEC process, with input from industry experts and stakeholders. The CSA standards are reviewed and approved by technical committees. Both the NEC and CSA standards development processes are designed to ensure that the codes are technically sound and reflect the latest safety practices. In addition to complying with the NEC and CSA standards, it is also important to follow any applicable local codes or regulations. Local codes may have additional requirements or restrictions for electrical installations in hazardous locations. It is the responsibility of the electrical contractor or engineer to ensure that the installation complies with all applicable codes and regulations. Failure to comply with codes and regulations can result in fines, penalties, or even legal action. It is also important to maintain a strong safety culture in the workplace. This includes promoting safety awareness, providing regular safety training, and encouraging employees to report any potential hazards. A strong safety culture can help prevent accidents and create a safer working environment for everyone. When working in hazardous locations, it is essential to wear appropriate personal protective equipment, or PPE. This may include items such as safety glasses, gloves, respirators, and flame-resistant clothing. The specific PPE requirements will depend on the hazards present in the location. It is important to follow all safety procedures and guidelines when working in hazardous locations. This includes using proper grounding techniques, avoiding the use of open flames or other ignition sources, and ensuring that all electrical equipment is properly maintained. By following these safety procedures, workers can reduce the risk of accidents and injuries. In the event of an emergency, it is important to know the proper procedures for evacuating the area and reporting the incident. Emergency procedures should be clearly posted and readily accessible. Emergency drills should be conducted regularly to ensure that workers are familiar with the procedures. A well-planned and executed emergency response can help minimize the impact of an accident. Proper design and installation of electrical systems in hazardous locations is extremely important for the safety of personnel and equipment, preventing explosions and fires. Familiarity with standards like NEC and CSA, adherence to local codes, and a robust safety culture are crucial for maintaining safe operations. Continuous training and staying updated with the latest revisions to standards ensures best practices are followed. The specific requirements for electrical equipment in hazardous locations can vary depending on the class, division, group, and temperature rating of the location. It is important to carefully consider these factors when selecting and installing electrical equipment. For example, a motor that is approved for use in a Class 1, Division 1, Group D location may not be suitable for use in a Class 1, Division 2, Group B location. Similarly, a motor with a temperature rating of T3 may not be suitable for use in a location where the ambient temperature exceeds the motor's temperature rating. It is also important to consider the environmental conditions in the location when selecting electrical equipment. For example, if the location is subject to extreme temperatures, humidity, or corrosive chemicals, it may be necessary to select equipment that is specifically designed to withstand these conditions. The installation of electrical equipment in hazardous locations should be performed by qualified personnel who are familiar with applicable codes and standards. The installation should be inspected and tested to ensure that it meets all requirements. Regular maintenance is also essential to ensure that the equipment continues to operate safely. The maintenance should be performed by qualified personnel and should include inspecting the equipment for damage, testing the grounding system, and verifying the integrity of explosion-proof enclosures. In addition to the electrical equipment itself, it is also important to consider the wiring methods used in hazardous locations. The NEC and CSA standards specify different wiring methods for different classes, divisions, and groups of hazardous locations. The wiring methods are designed to prevent the ignition of flammable gases or vapors. For example, in Class 1, Division 1 locations, the NEC requires the use of rigid metal conduit or threaded steel intermediate metal conduit. These wiring methods are designed to contain any explosion within the conduit and prevent it from igniting the surrounding atmosphere. In Class 1, Division 2 locations, the NEC allows the use of other wiring methods, such as cable with a gas-tight fitting. However, these wiring methods must be approved for use in Class 1, Division 2 locations. The selection of wiring methods should be based on the specific requirements of the hazardous location. It is important to consult with a qualified electrical engineer to ensure that the wiring methods are appropriate for the application. Grounding is another important consideration when installing electrical equipment in hazardous locations. The grounding system is designed to provide a low impedance path for fault current to return to the source. This helps to prevent electrical shock hazards and reduces the risk of ignition. The NEC and CSA standards specify different grounding requirements for different classes, divisions, and groups of hazardous locations. It is important to follow these requirements carefully to ensure that the grounding system is effective. Bonding is another important aspect of grounding. Bonding is the process of connecting all metal parts of the electrical system together to create a continuous electrical path. This helps to prevent voltage differences between metal parts, which can create a spark hazard. The NEC and CSA standards specify bonding requirements for hazardous locations. It is important to follow these requirements carefully to ensure that the bonding system is effective. Surge protection is also an important consideration in hazardous locations. Surges can damage electrical equipment and create a fire hazard. Surge protection devices, or SPDs, are designed to protect electrical equipment from surges. The NEC and CSA standards recommend the use of SPD in hazardous locations. The selection of SPD should be based on the specific requirements of the location. It is important to consult with a qualified electrical engineer to ensure that the SPD are appropriate for the application. In addition to the technical requirements for electrical equipment in hazardous locations, it is also important to consider the human factors. Human factors are the psychological and physiological characteristics of people that affect their performance. Human factors can play a significant role in accidents in hazardous locations. For example, fatigue, stress, and lack of training can all contribute to accident. It is important to design electrical systems in hazardous locations that are easy to use and maintain. This can help to reduce the risk of human error. It is also important to provide adequate training to personnel who work in hazardous locations. This training should cover the hazards present in the location, the proper procedures for operating electrical equipment, and the steps to take in case of an emergency. By considering human factors, it is possible to improve the safety of electrical systems in hazardous locations. In conclusion, electrical systems in hazardous locations require careful attention to detail and adherence to strict codes and standards. By following the guidelines outlined in the NEC and CSA standards, it is possible to design and install electrical systems that are safe and reliable. Continuous training, regular inspections, and a strong safety culture are essential for maintaining a safe working environment in hazardous locations.